Hello everyone. Today we are going to go over Bayes' rule, and this has to do with prior probabilities and determining the probability of if a person fits in this category, then what is the probability of outcome 1 and outcome 2. So the example that we're going to go over is athletes who are given drug tests who are actually drug users based on the results of those tests. So let's talk a little bit about the where these numbers come from. So the number of athletes is 100,000. That number is non-critical. It came from the book. We could use any number. We're after the probability here, not the actual number. And I will play with that number later on and show you why that number doesn't matter. In fact, you could take it out of the equation, but it makes it a little bit easier to learn up front. All right, the number of non-drug users and drug users. So that's sitting at 95% for non-drug users and 5% of athletes you're saying are drug users. Where could you find this kind of information? Surveys, you could potentially find that information in academic papers. Now I will tell you, your population of athletes may not match the population that was studied in those surveys and academic papers, but it could give you at least an idea. However, know that it may not be an exact match if you pull your numbers from there. All right. Now let's look at the number of athletes who test positive, which is, number of drug users who test positive. So that is a true positive, and I have it as a true negative, but it is not a true negative, it is a true positive. And so that is, again, it's people who use drugs who actually show positive on a drug test. And so the test is 93% accurate for that. Now, where would you find that number? You would find that number probably in an academic paper about the reliability of the particular test that you wanted to use. So there's only two outcomes that can potentially happen. And the first is that a drug user, a person who's a drug user tests positive, and there's a 93% chance of that. All the rest of them have to be drug users who test, if they are drug users, they have to test negative. There's only two options. If they're a drug user, they either have to test positive or negative. So we know that the percentage here is the inverse of this 93%. So we can calculate it pretty easily by going 1 minus 93%. And so we know that the number of drug users who test negative, which is a false negative, is a 7%. Likewise, we find that for this particular test, the non-drug users who test negative, which is a true negative, account for 97%. So it's 97% accurate for that population. And again, there's only two options for non-drug users. So if they don't test positive, they have to test negative. So we know that the number of non-drug users who test the number of non-drug users who test positive is 1 minus the number who test negative, or 3%. Now, our total number of drug users in this sample is going to be 100,000, because that's what we're saying our sample is, multiplied by the percentage of non-drug users in the population, so 95,000. And non-drug users is the percentage, or the 100,000 times the percentage that is not a drug user, or 5,000. Now, in order to find our Bayes probability, we are going to get mad. We are going to multiply, we're going to add, and then we're going to divide. First of all, we want to calculate the number of drug users who are going to test positive. Okay, so we can do that by taking the number of athletes times the number of drug users, or the percentage of those who are drug users, and then we're going to multiply that by the percentage that test positive. The percentage of drug users who test positive, which is going to be 93%. Okay? The next one we're going to do is the number of drug users who test negative. So we calculate the number of drug users, which we've already done twice so far. This will be the third time. We are going 100,000 times 5%, and then we are multiplying that by 7%, because 7% of them will test negative. So what that amounts to is 5,000 times 7%, or 350. Now, non-drug users who test positive, that is our 100,000 times are 95%, or it's this 95,000 right here. We could grab that cell too. I'm trying to show you as many times as possible how to do this. All right, so the non-drug users who test positive account for 3%, and our non-drug users who test negative is that 100,000 multiplied by 95%, and then multiplied by 97%. Okay? They account for 92,150 out of the sample. Now, we're going to add. We're going to add all who tested positive. So that's your 4,650 plus your 2,850. Okay? So you're adding the number of drug users who tested positive and the number of non-drug users who tested positive. And then next thing you're going to do is add to find out who all tested negative. So that is the number who tested negative plus number of drug users who tested negative plus the number of non-drug users who tested negative. All right, so we know that we had 7,500 who tested positive and 92,500 who tested negative. Now we are going to divide. Okay, so we're going to take the number of drug users who tested positive, so user and tested positive. See how we know this in the chart. So number of drug users who tested positive, we're going to divide that by the total number of people who tested positive. And we find that is 62%, and we're going to do almost the same thing over here. So we're going to take the number of non-users who tested positive and divide that by the total number of people who tested positive. Okay, and we find that that is 38%. Now, I'm not going to do it because I have this over here, but these should sum to 1. In fact, actually, I will do it. We will just check our math here. Okay, if these don't sum to 1, you did something wrong. All right, so now let's calculate the number who tested negative. So we're going to take the number of users who tested negative, which is 350. Oh, I forgot to put my equals in. Here we go. Take the 350, and we're going to divide that by all who tested negative. Okay, and then we are going to take the number of non-users who tested negative. Oh, no, that's not it. There we go. Non-users who tested negative. That's your 92,150, and we're going to divide that by all who tested negative, which is 92,500. Okay, and so we find that the test is pretty accurate in testing non-users who tested negative. So the athletics department can be sure, 99.6% sure, that if someone tested negative, that they are a non-user. However, the issue here is the positive tests and the false positives. So this is the significant number here, and that is that if somebody tests positive and you accuse them of being a drug user, you have a 38% chance of being incorrect. That's a pretty high probability that you're wrong. So even though this test looks pretty accurate on the surface, 93%, if you're accurate if you are a drug user, and 97% accurate if you're not a drug user, this is actually a pretty serious issue in that you have a really high probability of giving a false accusation. All right. You can also put all of the, I'm sorry, I promised that I would show you that this number up here didn't matter. We can do anything we want to this number, so let's put it at 50. And look, these numbers here change and shift, but these numbers down here do not. Okay, so you don't actually need the 100,000. You don't need this number at all. We can put it at 1, and which essentially takes it out. And you find that, you have the exact same probabilities. You don't actually need that number. If it helps you to put it in there to think through how to do the problem, then by all means, put it in. but you don't actually have to. See, I will show you here. I can take this number out. I'll take B6 out on all of them, and it doesn't change. It's not changing my probabilities. Okay? So again, if it helps you, feel free to include it, but you don't have to include it. See how my probabilities didn't change even though I took out B6, which was the number of athletes? Again, you are going to need this particular thing for your question 50 when you are analyzing the accuracy of a lie detector test. Alright, so my next video is going to show you more about using decision trees and how to use the software this week, but I wanted to show you this math concept. And remember, with Bayes, you get mad. You multiply, then you add, and then you divide. Hope this has been helpful. As always, if you have any questions, please feel free to call, email me. I am glad to help you. Have a great day.